These recordings are for the unit on temperature, heat, and thermodynamics. And this one is from chapter 15, number 5. What will be the final temperature of 100 grams of water? So 100 grams, that's only the amount here in the water glass, of 20 degrees Celsius, which is exactly 68 Fahrenheit, water when 100 grams of 40 degrees Celsius iron nails are submerged. So I'm just going to choose another color here. There we go. So 100 grams of iron nails, and they have a temperature of 40 degrees Celsius, submerged in it. So what's going to happen is that heat will flow from, and by the way, 40 degrees Celsius is 104 Fahrenheit. So we have 104 Fahrenheit nails here and 68 Fahrenheit water here, 40 Celsius, 20 Celsius. So heat will flow from the nails into the water. So heat will flow out of the nails, we call it Q, and heat will flow into the water, we call it Q in. Those two numbers are going to be the same. I'm going to use black again. So Q in into the water equals the heat out of the nails. Water. That was supposed to be an N, not males, but nails. There we go. Okay, the formula is given, and that one is C M delta T for the water, and on the other side it's, sorry, I'm writing somewhat up. Let's see, maybe this works a little bit better here, and then C M delta T for the nails. Okay, some numbers are given, such as the specific heat of iron is 0.12 calories per gram, 0.12 calories per gram and Celsius degrees. The mass of the iron is given as 100 grams, and then the temperature difference is going to be the initial temperature of the water, 40 degrees Celsius, minus the final temperature when the two are, when the heat has flown out of the nails into the water. Okay, then for the water it looks as follows. The specific heat capacity for water is the highest of all anyway, and it's defined as 1.0 calories per gram and Celsius degree. The mass of the water, they chose it in such a way that the mass is the same, so 100 grams times then 20 degrees Celsius. And now I didn't leave enough space, so I'll try to pull that over here. There we go. Minus, oops, I actually did that slightly wrong here. Let me see if I can fix that. Because I wanted to write the final temperature first, minus 20 degrees Celsius, and the reason is that the water will heat up. So with the final temperature larger than 20 degrees, I have a positive here, and over here the nails are going to cool down, so with the 40 minus the final temperature, I also have a positive over here. Okay, this one looks quite complicated. In fact, it is relatively complicated. There is a quick way and there is a long way. The long way here is first, and this is where I would solve algebraically for the final temperature. And it's going to look as follows. I'm going to try to make a nice fraction bar for a change. There we go. And I'm going to have the heat capacity of the water 1.0 times the temperature of the water, which is 20 degrees Celsius. And notice I leave out the units here so it doesn't get too long, plus the heat capacity of the metal, which is 0.12 times the the temperature of the nails. That's what I meant, yeah, metals, nails, 40 degrees Celsius, divide by the two heat capacities, 1.0 plus 0.12. And if you did the algebra, then you would figure out that indeed is what it is. As I said, I left out the units, so that means that the degrees Celsius here will survive for the final temperature. Notice that the 100 grams actually divided out. There we go. That's why they chose the same mass for the two. Okay, then when you multiply that out, you're going to come up with the following. I'm going to do this on the calculator. Okay, so let's see, parentheses 1 times 20 plus 0.12 times 40, parentheses, divide by the two added together, so 1.0 plus 0.12, parentheses, and I come up with 22.1 degrees Celsius as the final temperature. As you see, there was quite some algebra involved here in order to arrive at that end result. If we look at it and we say, well, does that result make sense? Well, we have the nails at 4 degrees Celsius and the water at 20 degrees Celsius. The water has a much higher heat capacity. That means it needs a whole lot more heat in order to heat up. That heat is not supplied because the nails have such a low heat capacity of 0.12. So that means that the final temperature should be relatively close to that of the water, and that's indeed what it is, relatively close, 22 degrees Celsius, which is in the neighborhood of 72 Fahrenheit. Okay, I said there is a quick way, and this quick way is an approximation, and it only works if the masses are the same. So here's the quick way. We compare the heat capacities of 1.0 and 0.12 and see what kind of ratio that is. So I divide the two, and when you do 1.0 divided by 0.12, you come up with roughly 8. If you do it a little bit more exact, you come up actually with 8.3 repeating. And now take the temperature difference, so between the two, that is, so 40 minus 20 degrees Celsius, and that should be written as actually Celsius degrees because it's a temperature difference. So Celsius degrees, and divide that by that ratio that I just computed, and you will see that you come up with 2.4 Celsius degrees, and I add that to the original temperature of the water, and I come up with 22.4 degrees Celsius. And as I said, it's only an approximation, and it's a quick way only because the masses are the same and I don't need to include those. So if you rather want to do it this quick way here, compare the heat capacities, divide that factor into the temperature difference between the two, and you come up relatively quickly with how much the water is heating up, by how much the water is heating up.